Hey everybody, welcome to the 2025 Summer of Protocols Town Hall. And this is our weekly guest talk series, an event where we explore the frontier of protocol studies with teachers, industry experts, founders, and researchers. Today's topic is somewhat of a continuation of last week's theme of public intelligence. Today is another talk about AI with Emmett Shear, the former CEO of Twitch and interim CEO of OpenAI. He will talk to us today about alignment protocols for AI agents. There are many proposals for alignment for collective intelligences, but this one is unique as far as I can tell, and it's an important problem. AI is one of the defining technologies of our time. It's one of the big three that we've spotted at Protocolize, which is climate AI and struggles over state capacity. So we're very happy to have Emmett sharing a protocol-based approach to the alignment problem. And welcome to the Protocol Town Hall, Emmett.
Thank you for having me. It's good to be here.
Yeah, thanks for joining. I'll add your slides to the stage and we can get rolling with your talk.
Awesome.
There you go.
So, already, for context, I've always been interested in AI my whole life. I've always been interested in community and connection and belonging my whole life, and I thought that these things would be separate, but it turns out that a lot of the thinking I've been doing about how connection and community work turn out to be quite relevant to how you think about AI and the future of the world. So I actually wound up starting a company recently, Softmax. Softmax focuses on this kind of alignment. So I am talking my own book, but the only reason I did it is because I think it's true. So, take it for what it's worth. So I want to start off by trying to convince you of one thing and sort of what this talk is about, which is that alignment between agents is a capability, not a property. It's something you do. It's a process that you can be more or less skilled at, and it's enabled by a protocol. And this contrasts to how people talk about alignment a lot of the time, where they talk about aligned agents as if the agent can be aligned or not. But agents are either capable of aligning and constantly aligning, or they're not aligned. So real quick, I want to talk about when I talk about an agent, what do I mean by an agent? An agent is an object. It's a thing you can see out in the world that is separate from you, that other people could intersubjectively agree is also there. And it has an OODA loop. So when you see this object, you can understand it better if you see it as having sensory information where it senses things, it orients itself around what it learned, it decides what to do, and it takes an action, and then it sees the result of its own action and repeats. And that's anything that has that property is an agent, which I will note bites the bullet and says that thermostats are agents. Thermostats have an OODA loop. They observe the temperature, they orient where they are versus the temperature, they update. Now they're a really small agent. Their internal state, their senses are really small informationally. Then very few bits going in and out. But okay, yeah. But we'll say a thermostat's an agent, even if it's a tiny one. And then what is alignment? Well, alignment is literally just being oriented in the same direction. Compasses are a classic alignment tool, right? They align their needle to north. You can align the furniture in a room. That's all kinds of alignment. And when people talk about aligning agents, what they're talking about is this aspect of agents that is key to any OODA loop, which is that to have an OODA loop to orient and to decide has this implicit existence of a goal. You can't orient and decide without a goal, because what are you orienting to? What are you deciding about? And so when you talk about aligning agents, that I can align agents as physical objects, right, and have everyone face the same direction in the room, but that's not what people mean when they say aligning agents. When they say aligning agents, they mean aligning the goals of the agents. They mean aligning what the agents want. And I got a slide for this. Oops. Anyways, but yes, you want the agents always be pointing in the same direction, and by the same direction we mean they're orienting in the same direction in goal space. They're trying to steer towards the same region of the possible states of the world. But it's more than that, because if we're both trying to steer to the same place, but I want to take a boat and you want to take a plane. We're trying to steer the world. Remember, we're not just trying to steer ourselves, take ourselves separately from the world. When agents act and observe, they're trying to bend not just their own internal states, but the state of the world into some favored condition. And so if I'm trying to take the favored state of the world and it goes left and you're trying to go right, we're actually going to be in conflict. We're not pointed in the same direction, even though we, in theory, want to end up in the same place. So it's not just about sharing an end goal. It's about sharing a trajectory, a preferred trajectory, or at least range of trajectories through space. And so I had a real hard time bringing this illustration for this one. But the problem with trying to show coordination about goals and paths is you end up showing like trajectories in the world. But the kinds of goals and paths we're talking about here are not someone walking around. It's about the invariance that we want to maintain about those paths. And so like, it's not that I care about the future states of the world, that they be at one specific temperature, the temperature go to a certain place, but rather not be too hot or too cold. I'm trying to maintain this invariant that it's within this range. And that's true at a bunch of different levels of abstraction. That's how goals work. So what a thermostat does, we're trying to maintain the system within a certain point. And the problem with trying to draw that is it's very abstract. So you just have to kind of conceptually imagine it. So I always think the easiest way to try to explain something like this, which is so abstract, is to actually then go through some very concrete examples. So the rest of the talk is mostly about that. Having set this up with some definitions, let's look at some ways that things do this and the protocols they use. So one of the most earliest forms of alignment is stress sharing via reactive oxygen species. So cells, as part of metabolizing, or just when they're exposed to oxygen, form these things called reactive oxygen species. Reactive oxygen species go right through the cell wall because they're tiny, and they mess up the cell's DNA. They mess up the cell's the machinery of the cell gets messed up by these reactive oxygen species, and so that's bad. It's like damage. It's going to kill you. So the cells learn ways to buffer these reactive oxygen species. They learn ways to do self-repair, and they learn to defend themselves against them. They get antioxidants. That's why everyone tells you to eat blueberries or whatever. But eventually, once they get good control over it, cells also learn that they can manufacture reactive oxygen species on purpose. And once you're pretty good at repairing yourself and protecting yourself against it, you can afford to create some reactive oxygen species on purpose and dump them out into the environment. And what this does is it poisons you a little bit and everyone, and it poisons you the most actually because you're the closest to your own reactive oxygen species, but it poisons everyone around you a little bit also. It's kind of like making a really painfully loud noise or something. That's obviously going to hurt you, but it hurts everyone else too. And what this does is this creates a basis for shared care, right? Because now my success and your success are tied together because cells only do this. Cells only stress share. They only dump reactive oxygen species when they're stressed. When they're under a lot of duress, they start to do this. And that means all the cells around me, when they start to feel this gradient of reactive oxygen species coming towards them, it's like, oh no, there's a lot of stress coming from this direction. That's like a proto-inflammation response. The other cells near you know, oh, there's something over there, and I can't be fully happy. I can't be low stress until that cell is also happy. And in this way, it ties their goals together. Now, because cells are doing this, necessarily, they're all going to share the same states of the world where they're happy, because if your neighbors aren't happy, you can't be happy either. And that creates this basis for mutual care. I think it's interesting that it's always negative. It's a lot easier to drip a little poison into the environment to hurt everybody than it is to distribute gifts into the environment to help everyone. Gifts are expensive. In theory, you can do both. The baseline tends to start with negative, I think just for ease of use. There's this other kind of biological example with cells, cyanobacteria. cyanobacteria form these, some species anyways, form these spherical colonies. And on the inside of the colony, they do the oxygen-sensitive process of nitrogen fixing, where they don't want oxygen. And on the outside, they photosynthesize and pull in the energy. And then the inside and the outside cells trade. And they learn to do this both from understanding their place by understanding this, understanding the oxygen gradient, the light gradient, but also they put out chemicals into the environment, hormones effectively, which are signaling compounds, so that they can tell how much other bacteria is this way versus that way. And the this is a protocol. It's a protocol for forming a colony. And what it really is a protocol for determining specialization. Hey, I'll do this part, you do that part. It lets them break up the set of things that need to be done for all of the bacteria to prosper, and lets the bacteria who are in this case better suited to each one, the ones on the outside or the inside, specialize in that, which is just more efficient. And that's the sort of next step after you have aligned goals, because cyanobacteria do the stress sharing thing. You can get some gain out of it, because now I already want everyone to be happy, not just myself. So it's already good for me to take action that helps myself, helps everybody. But also we can do it more efficiently now, because we can spread out the roles and coordinate on who's going to do what, because we have a shared understanding through this set of signals that tell us what to do. So this happens also in non-cellular things like emotional stress. Sadness is effectively a social stress sharing signal. Like, the purpose of sadness is it's like a virtualized version of stress sharing. I'm not actually pinging you with a chemical compound. I'm not damaging your system. I'm not like punching you or something. But like, if you already care about me, if there's already a basis for care, and at the next level up, my unhappiness is a signal about your own future unhappiness. And so for social animals, sadness is this way of saying, I am sad, and it hurts everything around you. It shares out the stress, and that directs resources. And joy is the opposite. It's like, I'm having a really good time, also is infectious and spreads out the joy. And, it's obviously much more complicated than that. When you get to the emotional layer, it's very, very complicated. But that's one of the most important functions of these emotions socially, is this sharing of reward and reinforcement of reward. Because they're virtual, if I don't already care about you, they don't matter. Like, the reactive oxygen species are kind of a foundational form of alignment protocol at sort of the bottom physical level, where you can't ignore it. It's going to hurt you if you don't deal with it. Whereas sadness sort of assumes there's already a basis for connection before you start to deploy it. I'll note that babies have a stronger version of this that knits them with the family more, the mom and dad more closely, which is they scream, and like, baby screams hurt. They're loud, painful screams, and that is that actually it disrupts your mental processes. It's actually hard on you, and that is, the baby is actually stress sharing you. Like, this isn't just sadness. This is like a little bit like the reactive oxygen species. Ouch. How do I make this thing stop? And that means your happiness and its happiness, the states of the world, are now tied together, which is very important. So the next thing that happens, you get all this stress sharing happening, and you have maybe a little bit of specialization. You have this evolution into multicellularity, and organisms start by being, individual cells, and they come together and they're transitionally multicellular, and they can stick together, or they can go it alone, and they can sort of decide, do I want to be part of this group or not? But humans are, I guess you could call us transitionally multicellular with each other in a certain way, but with cells, they can be part of it or not, and they can reproduce in either way. But the more time they spend together, the more specializations they learn, right? As you spend more and more of your time in this colony format, you start to develop more and more complicated protocols. You can see this is the human cell differentiation tree. It's possible to learn very complicated sets of rules about which kinds of cells turn to which other kinds of cells, what the conditions are. And this process of specialization proceeds. And then there's this special turning point that happens, which you develop a specific kind of role above and beyond specialization, which is you develop the immune system. Once one of the specializations is immune cell, cells that try to opt out of this multicellular deal are now the enemy. They're now something that doesn't belong here. And they are traitors, and they don't survive inside, at least not inside. They better get out, because if you're not playing your role as part of this thing, the immune system is not going to be happy with you. And at that point, you see this transition into multicellularity, into obligate multicellularity, where the only reproductive cycle now is the multicellular one. And that enables this explosion of specialization. It also really reinforces all of the mutual reward, because now none of us can reproduce at all without all of us reproducing. We're all in this together. We're all in the same boat. And so this self-reflective part of the protocol really tightens everything else up, because the way the immune system works, of course, is that it learns what is you. In order to do this, you have the cells have to learn to recognize self from other, which means you now have a protocol for alignment, but the protocol is a protocol that says that is the protocol of being self, and a model of what that self is, how to tell the difference. And this is cell wall proteins in biology, but it's corporate shibboleths and in cultural shibboleths when you're meeting a new human. Are you part of my team or not? Are you part of this thing? This is the first step. Immune systems are the first place where you start to see a system learn to know what is it and what is not it in a explicitly modeled way. And so this is an active alignment step. The organism is learning to align itself more. It's bringing itself into more alignment. And that's kind of the first immune systems are kind of unique in that way. So, I'm sorry, we talked about slime molds already. They're the transitionary ones. Okay. So, a little quick before we jump to human alignment. Cancer is therefore alignment failure, right? Cancer is what happens when some of your cells decide, wait, this is scary and bad. I'm not in the right place. I need to fend for myself. I just need to figure this out myself. I can't trust any of you other cells. And of course, in this case for cells, they're in a multicellular organism, they're always wrong. Like, that is just a mistake. But cells can make mistakes. You can make errors in trying to execute alignment. It's a skilled capacity, not like a universal state of being. So you can make a mistake. Humans are really, really good at this. Like, this is if I had to point at the thing we are a specialist in, even more than intelligence, we are specialists at alignment games. And in fact, I'd say our intelligence came from trying to play alignment games with each other more. That's the Machiavellian intelligence hypothesis, is that we became smart in order to be good at alignment, in order to be good at forming political factions. And we use tons of techniques for this. So let's just take a corporation, for example. Corporations generate alignment between employees by orienting everyone around a shared mission, by telling everyone at the weekly indoctrination ritual known as the all hands, this is our mission, this is our vision, this is our strategy. And because humans have an innate drive to desire to align, like, one of the most important things to us is to be part of something bigger than ourselves and to align to it. Just being told this is what we are all here to do functions to merge everyone's goal function a little bit, where everyone wants, okay, we're all trying to do that at least a little bit. And they also create things like management hierarchies. Management hierarchies are a way to make the whole system resonate. All the goals, all the orientation, the decisions, it's all oriented around the CEO. And basically it's made to lock the system to the CEO and make the system into an extension of the CEO's observations and decisions. And you, it's a little bit rigid, right? Because there's always the same center. Your body has a lot of hierarchies in it, but it's what I might call like a polyhierarchy. There's no like CEO of your body. There's lots of hierarchies that have different tops that are different, that are active at different times. That's like very hard to learn how to do. It's like the human body is an incredible piece of, machinery in a way. When we're designing things, it's much simpler to have a single hierarchy. It's much easier to think about, much easier to design. And so, we use these hierarchical things, but it's fundamentally the same. It's about synchronizing everyone's goals. And you have job families, which are a lot like cellular differentiation categories. Job families exist to make designing and managing the system practical, just like cell differentiations do. If every being has to improvise what's the right thing for me to do in this situation, it's a lot harder to figure out what to do. It's a very difficult problem. You'll get wrong a lot. Whereas if I'm this kind of engineer on this kind of team, I'm this kind of cell in this kind of organ, you can just act because you've got a script, and scripts are great because you can test scripts, you can iterate on them. And those scripts and the context you activate in them, that is the protocol you learn that at the specialization layer. And we learn it, and cells learn it. And anytime you have, ants learn it with worker ants and queen ants and warrior ants or whatever they call them. And so all of these things are trying to solve for the same kind of purpose. I like to think that you have things like auditors, and auditors are kind of like the immune system of the corporation. Police are kind of the immune system of society. In order to make these things work, you wind up bootstrapping all the way up to enforcement, all the way up to the system learning to discriminate what is self-behavior from other behavior. That's the purpose of corporate values, is to create a set of signifiers that says these kinds of behaviors, they are what we do, and these are not. And so if someone's not doing that, they're not us. They don't belong. And that's the core question you're asking over and over again, who belongs. So this is the alignment protocol stack. You've got at the bottom shared success. If you don't have some amount of shared success, if you don't have at least you're happy when they're happy and you're unhappy when they're happy in a correlated way, there's no basis for any of this. Like, why would I learn a whole protocol of specializing with in a role with you if I can't count on you caring about me as well? There's no ongoing glue tying everything together. Then you have specialization. Once you have this shared success, and once we succeed in the same worlds and fail in the same worlds to some degree, then you can start to specialize because you can count on the other things to care. So when you specialize, they will notice. When you send a signal, they'll listen, and you can start to coordinate much more effectively because you have this shared basis for understanding. And then once you have this thriving, specializing role society where people or cells are taking on jobs, and we really have become increasingly interdependent on the whole, you have to watch it. This becomes successful, and you have to watch out for free riders. You have to watch out for invaders trying to steal stuff. You need enforcement. You need some way to protect yourself against people who aren't playing nice. And that gets built on top of specialization. In fact, it is its own specialization, is enforcement. The way that people approach AI safety and alignment today is almost entirely backwards. People start with enforcement. How do we make the AI do what we want? How do we control? What's the audit system? How are we going to brainwash them, read their minds, reflectively adjust them to be aligned? We then think a little bit about specialization. Okay, I think the role for the AI is it's going to be a helpful assistant. This is how we want AIs to work with humans, but kind of in a rigid, way where we're starting from this idea of enforcement and then sort of asking, well, what roles would be easy for us to enforce over? And then at the very bottom and barely at all do we think about shared success. What would tie the states of the world where the AI is happy, where the AI is successful, whether if you don't think the AI is aware, which I think is a mistake, but let's say you don't, the states of the world that are low prediction error for the AI, that the optimization process steers into, how do you tie those in an ongoing, consistent way into the states of the world that humans like? And that we want to exist, because we don't agree with each other. We agree with locally. Like, I think my family and I have a lot of shared success, but like humans sometimes very much disagree about this. So you can't do it in a kind of global way. And the only like real answer to this question, right, is you have to start with shared success. You have to find some way where the AI understands that it is interdependent on the whole, where we share our stress and our reward with them. We learn to specialize, and we collectively figure out from this basis of shared care and mutual success, how do we specialize, and what jobs should the AIs do? What jobs should we do? And then on top of that, we do need enforcement. I think there's some people who are maybe more on the hippie woo side, who see the way that nature has this tendency to sort of directly towards alignment, which is true. It does have that tendency, and therefore don't like police and auditors and control. But like, a tendency is not a guarantee. The odds are not good enough unless you have some kind of enforcement. And so that's my pitch for what how to think about the creation of alignment. Is it goes through these building capacities at each of these stages. And each of these things is a protocol for bringing your values, your goals, your shared goals into alignment, for bringing your actions into alignment, and then for telling a protocol for telling who's participating in the whole thing or not. And you kind of have to do them in that order, or it doesn't work. And that's our talk for today. I can't hear you.
Oh, I was muted. Thank you. That was awesome. We do have some questions in the chat, but I wanted to sneak in a comment of my own first, since I'm being a selfish host. When I study safety protocols, one thing that we talk about a lot is how you can't really have safety if there's no underlying action. So like, the safest way to not get hurt on the way to work is just not to go to work. There's no risk if you stop commuting. And the same thing happens a lot with AI alignment. It's like, well, we need to figure out all the safety protocols beforehand, but the fastest way to have safety is just to have no underlying action.
Yes.
So that was great to hear.
So I think and I think actually what you do actually, if you actually want to build a bridge safely, is you don't do a shit ton of work up front to try to figure out how to build the longest bridge that's ever been created, 100 times longer than any bridge you've ever made before, safely. You build a smaller bridge and measure it and learn to build bridges that consistently stand up or fall down. And you learn the principles of bridge building. You learn rules, and then you start to scale it up, and then you see how those rules change as it scales, and you learn rules for how the rules change. And if you repeat that process and you keep cycling it up in a systematic way, you could arrive at the end with some real deep understanding of how bridges work. And then when you build the biggest bridge ever, it might actually stay up. And if you want to do this with AI alignment, you have to figure out how you generate mutual connection with really small models first, small models, and then bigger, because it's very dangerous to try to build a human level intelligent thing and align it for the first time on the first stab. If you think that alignment is something that you only care about once the thing gets big, that you're going to figure out in advance. That's like terrifyingly dangerous to me, in my opinion. Like, I really don't approve. I think we need to start small, which is the approach we're taking.
Yeah, it's like this attempt to have like a perfect run at a game that you've never played before and have a zero incident policy.
Yeah. And we can't watch a bunch of copies of the game, but we'll like you know, we'll think we've looked at the source code and we'll think real hard about how we think you might play it. It's like, this is just not a good idea. It's not the right approach to this problem.
Okay, here's a question from Venkat. One of the SOP researchers, Kia Krutler, made a persuasive case that memory should be seen as an orientation function in the OODA sense. You're treating orientation in the OODA sense as the basis for alignment. Can you try to connect your view to memory in evolving systems?
Yeah, absolutely. So when you think about what an OODA loop is doing in a learning system, like if you like not what it feels like, but like what's actually happening is sensory information comes in and it's usually way too high of bandwidth for all of it to be saved. Like there's just, the amount of optic nerve information, neural impulses coming in, through your eyes, like vastly higher than you could possibly save all of it. So there's this process of filtering and summarizing, and like you throw away a bunch of data and you do that based on your existing understanding of the world. What things in your vision pop out is based on what you already understand to be important, because you have to choose up front. But you get some amount of data sort of extracted, pulled out of that sensory flow, and then you have to like somehow combine it with what you already know. And the problem is, like, you can't just make copies of yourself. So if you could just make infinite copies of yourself, you would like keep your old self, and then you would also make a new copy with the other stuff and integrate all the changes that these new insights imply. But you can't do that. We don't have space. No finite being has space for that, right? You're using all of you all the time. You don't have like an extra place to put new you. So the only way that you can, in a running learning system that isn't constantly growing at some absurd pace, the only way you could possibly orient is by remembering. The first thing you do as the sensory data comes in, after it's, there's some extraction, but then the first thing you do is you remember it. You update yourself to reflect me plus this new insight, and that points you in a slightly new direction. Your goals change a little tiny bit. Your way the world works changes a little tiny bit, and then from there's a process of the echo of that coming back out. That new thing generates well, therefore this is what I should do, and that's the decide, and then that flows out into action. And the whole system, in the heart of that system, is I sometimes call it like a magic mirror, right? It's a mirror of reality, because the thing that is changing has to reflect reality, but it doesn't reflect. It's not like a mirror that just reflects what's happening in this very moment. It reflects the underlying causal dynamics of reality as best you understand them, and that is like constantly in motion. And that is your memory. Your memory isn't anything other than that model. It's like your brain has there's some separate you that isn't your memory. The whole thing is memory.
Kia's got this great term that's also the name of her consultancy that she recently launched, which is inner library. And it's like, if you think about a library and like the process of overhauling that, like you could never do the whole thing all at once. It's like this incremental process where you're gonna have to take a book out, put a new book in, and change it piece by piece over time. We have a question from Tim Bako, who's one of the program directors and who leads the all core devs calls at Ethereum. Misalignment is often thought of in binary terms. What's your intuition on where the breaking point is? What's the maximum distance between two alignment vectors that can be bridged?
So in theory, all learning systems are infinitely plastic. Like there's no state of beliefs that you can't move out of, given a sufficient amount of sort of like evidence for a learning system, right? Or if you are, you're sort of a bad learning system. And in general, learning systems can always get out. The problem is like, that's like saying like there's no hill so tall you can't climb it with enough energy. Like, yeah, that's true. if you're in a deep enough valley, you're not getting out of that valley. And if the walls are high enough, you're not crossing that mountain range. And the way to think about alignment is instead of so alignment isn't vectors. The agents are these trajectories, these vectors, but alignment is the attractor basin that those vectors are in that keeps your vector starts to move away from the previous trajectory. Your trajectory starts to change, and it there's some force that's pushing you so you stay in a certain valley. And if you're in the same valley as someone else, you're aligned. Now, the world's really complicated. That makes it sound like there's a single landscape, but actually there's infinite landscapes like this. So you can be in many alignment values at once. Motion in one implicates motion in another. Like, reality is hard. None of this is like simple, but the right mental model is these attractor basins. And it's more like how many planets will form in a solar system than it is like, how do you align two things at each other? It's like how many center points pull things into them separately and create a center of gravity, so to speak.
Awesome. I'll bring up one more question here before I bring Venkat on the stage, and he can take over the rest of the Q&A. He's got lots of questions. From Daniel Kronovit, who is a writer who contributes a lot to the protocol community, SOP. Is there a too small setting for experimentation? Would aligning two people be a useful base case, or would that be uninteresting?
There is not a too small setting. You can have alignment between two agents. Humans are the end boss for this game, right? Humans are. I started to think about things in terms of sort of their informational the size of their memory, and every human walking around is like, it's like a Mount Everest. We're gigantic. It's like I can't. The size of what goes on inside of the simplest human is just so. There are these giant systems that have this huge amount of gravity, sort of like alignment gravity to them. It's very complicated. And I hope someday to be able to give you some kind of systematic way to like read off what's going on in a human. But the problem is, whenever you put two humans in an experiment, they're not just playing the game you want them to be playing. They're playing a dozen other games at the same time. Everything they're doing implicates that you can't take them out of these greater wholes that they're part of. So you're always in this very complicated landscape, and it's really hard to read off what's actually happening, right? Because you have to model the whole thing. Instead, the setting we're going for really small is imagine an artificial neural network, but imagine one with, instead of billions or trillions of parameters, imagine you go down to like, I don't know, a couple million parameters. Like, what's the smallest agent you can build that can still do things as complicated as alignment, because the things I'm describing are not simple. And that's, I think, the smallest setting. But yeah, two agents is small enough. I don't think people are simple enough.
Yeah, I'll bring Venkat on, who has a great concept about evolutionary time and how like training a model is kind of like getting it up to speed on like thousands and hundreds of thousands of years of evolution that the creatures have gone through. So you're basically speed running that. Okay, I'll let you guys run with this.
Right. Hey, Emmett. Yeah, sorry I couldn't join earlier. I had some television interference. I'm here in India. But yeah, great talk. Yeah, you and I have talked before, and you've kind of like hinted at some of these ideas you're developing, and it's really good to see like some of it take shape here, and there's lots of places we could sort of take this conversation. But one I wanted to ask about is the extensive biological analogy you made with like immune systems and stuff. Can we extend that a little bit? Like, how should we think of autoimmune diseases and say parasitism and symbiosis in this framework?
Yeah. So, I mean, you could say that symbiosis is alignment, right? Like, in many ways, I'm saying the important, you can create sort of enforcement first hierarchies that are not symbiotic. But like sustainable alignment is always symbiosis, because otherwise one part of the system doesn't want to be in it, and eventually it will eventually win. You might think the enforcement will last for a while, and the Stasi does work kind of, but like it's not a sustainable approach. When you think about like parasites, autoimmune disorders, like I think one of the most important things about biology, and this actually is a fact about, I think, learning systems in general, is that there's everything's under constant attack because learning systems can be tricked. And if I can just slip in and start consuming your resources without giving back, that's like always an efficient strategy. And so you get predation, you get parasitism, you get all those things, and then naturally organisms start to defend themselves, but the thing that is the self model of like what is me, what is not me, isn't always good, and so inevitably, if it's mistuned or miscalibrated in some way, it's going to start attacking things that are actually you, and I'm also, honestly, the human immune system is incredible. I'm shocked we don't get more autoimmune disorders. Like the fact that it can so precisely, with all the diversity of stuff that's happening, and you pick out that's bad and that's me, and I can leave it alone. Like it's quite amazing.
Yeah, but I think the strength of your model, as opposed to the alignment with goals model, is you can make mistakes that lead to these phenomena like parasitism and others, but it's a capability. You have like multiple chances to get it right. You keep learning, and sometimes, it might start like as you were speaking about, like babies crying. It reminded me of this research that cats have evolved actually to very closely mimic the crying of babies, right? The meowing of cats. And that could be considered parasitism, but we like cats and we treat them as pets. So it's like actually kind of works out, right? So it's partly interpretation. But let's kind of stress test this a little bit because I think the traditional alignment people who, honestly, I really have big problems with, the goal-oriented ones, they would argue, I think, something along the lines of, if the risk is big enough in some tail risk sense, it's an X risk level thing, then you don't get multiple shots to iteratively learn and align in the sense of a capability. In that case, alignment will reduce to like a consequentialist one-shot learning problem or something, right? I don't think it's a credible criticism, but I can't quite put my finger on why it feels wrong.
Yeah. I mean, I think they're right. If you go about doing it the way they want to do it, that is what will happen. Because if the way you go about trying to align the AI is you build something really, really powerful and then you try to align it, that is a one-shot thing where it's either in the attractor with you or it's not. And if it's not, you're fucked. And like, that's true. That's why you shouldn't approach it that way. But it's funny because it's, as I've gotten older, I've started to really believe in like manifestation. Like we really do manifest our beliefs, but that's what this process is about, right? We take action to bring our model into being. If you believe that that's how it's going to go, you act to make it so. And I think the mistake they're making there is they think that alignment is about the top of the protocol stack. They think it's about enforcement. And the problem is that enforcement is extremely brittle. Enforcement requires you to not make mistakes. And when you do make mistakes, you get a coup and everything's over. And that happens. Countries happen. They fail enforcement and it's game over. It happens all the time. The thing that keeps humans alive, that keeps biological systems working, is that the bottom of the stack isn't about not making mistakes. It's about orienting the things so they want to stay in the attractor. They're trying to stay in the attractor. Like once you're in it and you're codependent on it, and you start to see the rest of it as stuff you care about, because it's also you. It's also like its success is your success is its success. It models the world like you. It is you. It's partially you. And so once you're in the attractor, and you actually you build mutual care, which is a real phenomenon that actually happens, that becomes the gradient where the things are intentionally trying to stay more aligned. They're developing immune systems. They're making enforcement mechanisms spontaneously. They're trying to keep themselves in the attractor. And the result of that is that as the things get smarter, if they're in the attractor, they align themselves better, not worse. Intelligence starts to work in your favor. But the problem is you have to get into the attractor when it's small, and you have to cycle it enough. There's enough evidence, mutual evidence to everyone that, hey, we are all in this attractor together. And then the other thing you want to do is what we do with corporations and humans and tribes is like, you don't want to build one giant omni AI that is the super AI that's bigger than everything else. You build lots of AIs that are not aligned to all of humanity, because we're not all aligned with each other, but that are aligned locally to the people around them that they interact with. And then if one of these things goes wrong, there's a bunch of other ones to clean up the mess. And that's really, the backups are important. You don't want to do this with a singleton. The singleton's a bad idea.
So this is almost suggest, okay, so the way I would summarize what you just said is alignment almost lies in how you build and evolve the AI. So if we were to make a nuclear bombs analogy, the answer would be, don't build the biggest bomb possible with like a coin toss decision that can either make it explode or not explode. Build like a multi-agent kind of, well, lots of little nukes. I don't know if that's any better, but I think in a way, the reason your model is elegant is I think it creates like a deeper justification for a multi-agent approach to AI. There's almost like an ergodicity hypothesis here, which is that if there's like multiple agency in how the system sets itself up and evolves and gets smarter, it'll naturally have the kind of iterative alignment capabilities. And instead of having like a monolithic AI with like a monolithic and brittle way of trying to like control and govern it, it would sort of like organically have an immune system sort of co-evolving with it, and we would be part of that. And it would kind of like, if we'd get things like autoimmune diseases and parasitism and predation, which might be bad, but they kind of feel like they're within the normal realm of like statistical phenomena, as opposed to like these monolith versus monolithic control strategy thing. But while we're on this topic, let's quickly put Corey Levinson's comment/question on the theme. Yeah, there's a good question. Yeah, what's the... Yeah, how should we actually... I think AGI also is a problematic term, but this question of like, what is a test for alignment is a good one, I think. So,
yeah. So I think I want to go back a little bit to the multi-agent thing you said, which I think is very related to this question. If you think about the agent's behavior, the agents being little particles, and they have some trajectory. And in this case, unlike electrons and protons, they have memory, they have state, but they're stateful particles that have some trajectory in some big high dimensional space. Everything we know at statistical physics applies to agents as well as to particles, which is to say, when you have a small number, you can't model it as having macro states at all. There are no macro states because variance of the individuals in the system overwhelms any statistical properties of it. But if you have 28 trillion particles, you have 28 trillion cells, your body functions because you're made out of 28 trillion cells. There's a reason that biology doesn't scale up lots of cells that are really big. You want more because that means the macro states become more predictable and more powerful. And so we want to have as many AIs as possible in some sense, because that gives you this macro state predictable stability, the way that temperature and pressure and volume are more predictable than the individual velocities of the particles. Mm-hmm. And the way this applies to this sort of like solving AGI is like, there is no solving AGI. There is no aligning. There is no like having arrived or non-arrived. There's only like the system in motion and its dynamics. And like at some point, the net balance of sort of causal pressure will move from really like the human collective to a human and AI collective. And if we don't screw it up, that hybrid collective will remain coherent. And what you'll get is it will divide not as human versus AI, but as clusters of human and AI versus each other, which is what we have today, is just clusters of humans versus each other. And that's like that's okay. We've lived with that for a long time. And yeah.
This is I'm kind of like almost surprised more people don't think of this in this way, because it's actually one of the oldest ways of thinking about like alignment in AI. Like if you look at Asimov's 3 laws of robotics, that's like a monolithic positronic brain that's governed by 3 kind of like top-down authoritarian laws. And if you've read the Asimov canon, the in-world chronology is literally the Daniel Oliver robot saying, "Hey, let's invent psychohistory by moving this to the statistical physics realm," right? So that's literally how Asimov goes from the 3 laws of robotics to psychohistory, right? Was that part of your thinking at all?
No, when I realized retrospectively that I'd just gone through Asimov's, I was like, oh my God, he was, and I'm sure like I read those as a kid. If Asimov was the first sci-fi that I loved, and I read everything he ever wrote, and like I'm sure that partially has influenced how I see this, right? Even though I didn't think of it consciously.
I do want to drop in another reference, which I think if you haven't come across, you'll really love. Axelrod and Bennett wrote this great paper, I think in the 80s, called Landscape Theory of Aggregation. So they literally use spin glass models, which are, I'm sure you're familiar, the models of like physics, magnetic domains, to model and predict alignment in the Axis and Allied powers in World War II. It came out perfectly. And I remember reading that at the time and saying, this makes a lot of sense. If you ask me to actually describe the quote-unquote goal of the Axis and Allied powers in World War II, I would really struggle. Like, what the hell did Hitler want? Nobody knows. Yeah, but that doesn't stop you from actually figuring out who's going to align with who, and you don't need to understand the sort of like consequentialist logic of it. You can just work with like, alignment in sort of the spin glass magnetic sense, which I think actually is a good point to like try and like talk about the philosophy of this. Like in a way, I take what you're doing here as a strong vote for a deontological ethics over a consequentialist or virtue ethics approach. Is that a fair reading in an ethics sense?
Sort of. I mean, I think actually in some ways I think of it as a virtue ethics thing, because what I'm saying is there's a virtue, which is like aligning, basically this capability. It's a middle way of you can't over-synchronize. Over-synchronize, you want everyone locked in lockstep in this hierarchy. That doesn't work because you don't have adaptability. Under-synchronize, you're a gas. You can't coordinate anything. But like, actually what I've really come to believe, the real philosophical thing behind this is it's really being driven by the Buddhist concept of emptiness, right? Like sunyata or whatever, this idea that like, there is no actual case. There is no fact of the matter that's like the real way it is, separate from just like, the normal everyday way it is. Like, is this action moral? Well, yeah, I mean, I don't know. Was it good for the flourishing of the group you're in and like, of benefit? No, but was it really moral? Like and it's like, that question doesn't have an answer. It's like speed.
Yeah.
How fast is the object going? I don't know, man. Like, who's asking? And like, I increasingly believe that about morality, alignment, goals. Like, is this correct? Is this right? Are we on the same team? It's a matter of perspective. It's a matter of, it literally is a matter of, not like you get to make it up. It's like, no, seriously, there's math. What perspective are you in? That tells you like, and I think there's been deep confusion in the West. I mean, really everywhere too, but like I'm just coming at it from the Western side because that's what I understand, between subjectivity and relativity. And what I'm really saying is everything is incredibly relative. You cannot answer the question of whether this is right action or not, whether this is moral or not, without choosing a context to ask it from. It doesn't have an absolute answer, but that doesn't mean it's subjective. Like, it doesn't mean that it's an internal fact. It's a fact about your relations. It's a fact about how the system, parts of the system relate to each other. And things like emotions are subjective as well. They're internal to you. They're not happening outside of you. Obviously, they're subjectivity things. It turns out to be really easy to tell what's subjective. It's stuff that happens inside, not stuff that happens outside. But they're also relative because they're subjective. They're always relative to you. And so there's this. I basically think that we've gotten very confused where we think that when someone says morality is relative, they're saying that it's like emotions. It's like this thing you're making up inside you, which I think is just totally absurd.
I think this Buddhist kind of perspective is actually like very load bearing, and it would be really good to insert it into the discourse. Like as you were speaking, it kind of like almost flippant line occurred to me that maybe we should think of it as before alignment, chop wood and carry water, and after alignment, chop wood and carry water. Right? It's not a task you finish. It's not like you're one and done. You're now perfectly aligned with the AI. It's
Finally
like,
aligned.
we're going to go on with
Good.
Yeah, this is I think the conversation about alignment we should be having, and unfortunately it kind of gets lost in like I don't know, esoterica essentially. But I think we have a couple more minutes. There's one more line of thought I think would be interesting to talk about for a few minutes. You showed the classic meme diagram of like the org charts of various tech companies, and I think that's a very good lens to get into the practicalities of it, right? So you've got like org charts, and one of the things we do at that scale and sophistication of alignment is we do bring goals back in, right? Like you said, organizations tend to have like mission statements, vision statements, so they like use goals as like orientation constructs that are like legible and explicit and go beyond like capabilities and virtue ethics. And when we look at it from that level, where it's like more of like a engineering approach to it, you can also, I think that's the right frame to talk about like what we actually do in the name of alignment, right? Like RLHF and all these other like practical techniques we do to actually do quote unquote alignment today, which kind of resemble things like, a CEO saying this is the vision statement for the company. And while you're in the company, leave your various other personality bits behind. Here you are like a XYZ type engineer doing this job, right? So it feels like that's a practical way to approach alignment and goals. So yeah, any thoughts on like that practicality of it and that? Yeah.
I think these techniques that we develop inside of corporations are designed to work on autonomous beings who need to be persuaded and who respond to incentives. And what that assumes is that these beings inside the corporation have a stable sense of self and a stable sense of their own goals, which can be shaped. The biggest mistake we're making in alignment today is where people think we want to remove agency from the AI. Let's make it so it doesn't have goals. We don't want it to have its own separate goals. But the problem is that something that doesn't know what its goals are, doesn't not have goals. It just doesn't understand what its goals are. And it's the danger there is that I can't align my goals with you if you don't have goals or know what they are. I can't shape your what you want to do with incentives if you don't respond to incentives. I can try to control you. I can try to dictate your actions, but then I'm going to fuck up at some point, and I'm going to dictate your actions.
So let's chase that thought down, since you began with kind of like the what some would call an extremist position of saying a thermostat with a set point is an agent capable of alignment because it's reference temperature is its alignment vector and so forth. But sounds like the way you're describing it at the human organizational level, a thermostat would not qualify in some deeper sense. It's not maybe adaptive enough in its set points or something.
Thermostats are just really shitty at alignment. They're like, they're an agent with a goal, but like we'd have to do all the work. We do all the work. We set the thermostat. The thermostat doesn't set us. And like the problem is that like that works fine. We're used to aligning with learning systems around us in a hierarchical way because we're used to them being much smaller than us so that we can do that. We can train a dog and the dog doesn't train. It trains us back a little bit. Like it's actually dogs are powerful or good enough. Your cat does train you a little bit, but the ratio is still very much, we're much bigger, it's much smaller. We're moving into a world where it has the capacity to train us back as much as we train it. And in that world, there's a kind of strike you can go on in a company. It's called the work to rule strike, where you just follow orders. You start to do what you're told. It grinds companies to their fucking knees. You cannot run a company with your employees doing what you tell them to do. Every company relies on all of those rules you've made about what proper behavior is. They get violated constantly, and you should thank your lucky stars. If they didn't, your company would never work. And what this is the kind of alignment that we need to seek is to have AIs in your company that will break your rules because they know that what matters here is like, yeah, we'll follow the rules, like, when they're important, but like sometimes you got to break it, and because they care about the outcome, and about being part, this whole being healthy, not about following some rule you told, not about obedience. And like, I really wish I could take everyone who's in the alignment discourse and make them run a corporation for a while, because like when you've had to deal with employees, it's like, oh yeah, no, I can't. Rule followers are like, they're the worst. They're so annoying because it's like they it's hard to get mad at them. Like, you did say to do that, but I didn't mean like do that. I meant like do the smart thing.
This is I think this is another lesson that needs to sink in along with the chop wood carry water thing. It's like it's actually more dangerous to have AIs around that are not willing to break rules in the spirit of the law while violating the letter of the law. That's actually the word for that is not alignment. The work to rule is the conscious like protest strategy, but the clueless version of that is actually more dangerous, where it's like you're not oriented, you're not capable of orienting, and you're like a bigger danger to aligned activity than somebody who's actually trying to maliciously or negligently do something, right? Yeah.
There's a lot more of you. You're all over the place.
Yeah, and it doesn't take as much smarts to do this. All right, with that, we're at the hour. I'll invite Timber back on to wrap us up.
Thank you so much, Emmett, for joining. That was a very interesting discussion, and the Q&A was awesome. The recording will be up on YouTube, and we're going to start experimenting with turning these into like podcasts retroactively. So there should be like just an audio file for people to listen back to. I'll take you guys off the stage. Thanks very much for joining.
Thanks for having me.
Thanks everybody for watching. The next talk is with me, actually, next Wednesday, May 7th at 10 a.m. Pacific. I'll be talking about tensions, engineered arguments, hardened commons next week on Substack, not YouTube. So tune in there, subscribe to the newsletter, Protocolized. And yeah, cheers.